Okay, this is part 3 of our a little bit of algebra, and I want to move this a little more closer to amateur radio. And the technician level test has a number of Ohm's law questions in it, as does the general test has some, and even the extra amateur has some, especially with power. So let's look at probably the best known equation, Ohm's law. And Ohm's law states that the voltage is equal to the current times the resistance. So maybe we have a little circuit here. And this could be our 12-volt battery in our car, and maybe this is a headlight filament or something. All right. Now, first of all, you notice that there are no numbers in here. This is the general form of the equation. You'll also notice that I'm using the letter E. And those of you that are younger may kind of wonder at that, scratching your head. Well, I thought they used V. And you're absolutely correct. Most currently, V is used in favor of E. E stood for electromotive force. I is the French word for current. I don't know what that is, but it starts with an I. And R for resistance, that one's pretty obvious. In the beginning, they didn't use V for voltage because way back in the days of tubes, and the Brits were really great pioneers in building tubes, tube radios, and so forth, they call their tubes valves and labeled them schematics using the symbol V. So when Ohm's law came along, V was really already kind of taken, so they used E for electromotive force, which is kind of a technical term for voltage. But they're interchangeable. But for the sake of the younger ones here, I'll use V, since that's more common today. We hardly see tubes anymore. Okay, so the voltage then is equal to the current times the resistance. We know this is being multiplied because these two letters are next to each other with no intervening mass symbol like plus or minus. So it means multiplying. All right, so let's make up a little problem here. I know that my voltage is 12 volts. And I took out my ohm meter, disconnected the cable from my headlamp, the plug on the back of it, and measured between the two prongs that represented the element inside the headlight that lights up, and it measured 4 ohms. And my question is, how much current is flowing through the circuit if I have 12-volt supply and my resistance is 4 ohms? Okay, so we have everything filled in except the I. So I is our variable and what we want to put our focus on. What's being done to it? It's being multiplied by this 4. Well, how do I undo multiplication? Divide, but I must do it to both sides. So I just got in the habit of writing that divide. If I divide this side, I immediately put it over here too. I want to divide by the 4. The 4's cancel out to 1, So I then is equal to 12 divided by 4 is 3. And that's in amps. We're dealing with ohms, amps, and volts. And I won't make that quite so big. So 3, and I'll just put amp down here as a subscript. So we know then when we turn on our headlight, well, we only have one headlight here, but I am drawing 3 amps of current out of that battery. Kind of gives you an idea of why it doesn't take very long to draw your battery down if you leave your headlights on. Okay. Anyway, the important part here, though, is what we did with this equation. We took 2 of the values that we knew, and then by using a little bit of algebra, we were able to solve that for the current. Okay, well, look what you can do. Let's not do any numbers here, and let's solve this equation for the same thing for I. We divide by r because we want I by itself. We divide by r, but we have to do it to both sides. R over r, it doesn't matter what value r turns out to be, it's going to cancel out. It's going to be 1. So we have created another. Here's our first one. This equation is solved for voltage if we know the current and resistance. We've now created a second equation. I is equal to V over R. All right, great. So let's do that again, but this time let's solve it for R. So V then is equal to IR. I want R by itself. Well, I is multiplying by R, so let's divide both sides and divide both sides by I. Those cancel, so now I get my third Ohm's law equation. R then is equal to the voltage divided by the current. Now, many beginning algebra students find these literal equations a little harder to deal with because there's no numbers. We get used to the idea of working lots of equations with numbers, but when we get to them where they're all letters, then sometimes we get questions about that. And you're going to see in study guides, I got to look in the license manual and see how they do it. But oftentimes you're given this circle, and they'll draw a line here, and like this, and they'll put E or V, I, R. And you simply cover up the one that you want to know, and it will tell you what it is. So if you covered up this E is equal to I times R. If you covered up this R, it's E over I. If you covered up this I, it's E over R. Well, that's great as long as you can remember what order things go in the circle. It's much better if you can take the beginning equation, V is equal to IR, and know a little bit of algebra to be able to derive the other two. I can divide both sides by R, and I get I what I equals. I can then write the equation again and divide both sides by R, and that gives me what R equals. So really you only need to memorize the first equation, because now that you know a little bit of algebra, you can derive the other two equations. I like this idea, but I oftentimes can't remember. This one's not too bad because I've dealt with Ohm's law a lot, but this wheel works for other things too, and I always forget what goes where. but I know how to do algebra, so I can always derive my equations. All right, more in the next video.